Hello, for this problem we are asked to determine the sum of these force vectors shown in the diagram below. We need to give the answer, so that total force vector in terms of a magnitude and a direction. So just for labeling purposes, I need to add a few things to my diagram. I need to label my axes, and so I'm going to do X is horizontal, Y is vertical. I also need to label my forces. I'm going to call this one F1, this one down here F2, and this third one F3. And then, just for simplicity's sake later on, I am also going to label kind of this angle, this 90-degree angle right here, as a little bit weird. I want to measure it either from horizontal or vertical, so I can figure that out by just using some simple logic. And so this right here is 90 degrees, and I know F2, I go out 30 degrees, and if this is vertical, I need to go out another 60 degrees to get to horizontal. And so this is going to be 60 degrees, and if the total is 90 degrees, I go another 30 degrees up here. So that little bit of logic is going to help me later on figure out the X and Y components. So now I need to do that. I'm going to figure out my X and Y components for these force vectors, and I need to break each of these down. So that first one, F1, I draw out my triangle. The length of the hypotenuse is going to be 5 kilonewtons. And my angle going up from horizontal is 30 degrees here. And so this is F1y, and this is F1x down here. So F1x is going in the negative x direction, so negative 5, and it is the adjacent side in my triangle, so negative 5 times the cosine of 30 degrees. That is negative 4.33 kilonewtons. F1y is going to be positive, and it is 5 times the sine of 30 degrees, since it's the opposite side. And that is 2.5 kilonewtons. Alright, next I've got F2. So if I draw this diagram in here, this is 6 kilonewtons for my hypotenuse. And I know it is 30 degrees out from vertical. And so this down here is F2x, and this one is F2y. Alright, so F2x is in the negative x direction, and it is going to be the opposite side. So it is negative 6 times the sine of 30 degrees. So that is negative 3 kilonewtons. F2y is going to be down, so it is negative as well, negative 6. And since it's the adjacent side, it's going to be the cosine of 30 degrees. And that is negative 5.20 kilonewtons. Alright, and the last one, so I've got this third vector, and that one is going to be simply 5 kilonewtons straight down. So F3x, this is equal to 0, and F3y is equal to negative 5 kilonewtons. Alright, so to find the sum of these three vectors, I simply need to add up the x components and add up all the y components, and that gives me the x component and the y component of the sum vector. So Fx, this is the total force, so the net force, is going to be equal to negative 4.33 minus 3 plus 0. And so my total is negative 7.33 kilonewtons. That's the x component of my sum vector. Alright, so in the y direction, I just add up all my y components. That is going to be positive 2.5 minus 5.20 minus 5, and that sum is negative 7.70 kilonewtons. Alright, so this is the x component and the y component of my sum. Now I need to go in and I need to figure out the overall magnitude and the direction. So if I've got my, let's draw in my y and my x directions, I'm going negative, and it's pretty close to like a 45-degree angle. I go a little bit more down in the y direction than in the x direction. So I'm going kind of in that direction. Alright, so I want to draw in my triangle here. I'm going to draw this in kind of like so. And so this is going to be my angle theta. I need to figure out what the overall magnitude is. And I know that the y component, this is negative 7.70, and the x component is a negative 7.33 kilonewtons. Alright, so the magnitude of the force, I use the bars to indicate the magnitude, is going to be the square root of my two legs, just Pythagorean theorem. So negative 7.33, I square that whole thing, and negative 7.70, square that whole thing, take the square root, and I find an overall magnitude of 10.63 kilonewtons. And so that is the magnitude right there. Alright, to find theta, I'm going to use the tangent is equal to the opposite over the adjacent. So theta is equal to the inverse tangent of opposite over adjacent, negative 7.33 over negative 7.70. And if I do that calculation, I find my angle theta, and theta is going to be equal to 43.6 degrees. And that is measured out from my vertical there. So this is my overall magnitude, this is my overall direction of the sum of those two force or the sum of those three force vectors that I had in my original problem. So thank you for watching, and I hope to see you again.